All right, everyone. I am here with Vered Shwartz. Vered is a postdoctoral researcher at the Allen Institute for Artificial Intelligence and the Paul G. Allen School of Computer Science and Engineering at the University of Washington. Vered, welcome to the TWiML AI podcast.
Thanks, Sam. It's nice to be here.
It's great to have you on the show, and I'm looking forward to a really interesting chat about NLP and some of your research in that area. To get us started, I'd love to have you share a bit about your background and how you came to work in AI and NLP.
Sure. So I took 2 NLP courses in the last year of undergrad, and I really enjoyed them. And then I was planning to maybe go work in industry for a year and maybe go back to do a master's degree. And then coincidentally, the university has advertised some student exchange program that looked very tempting. So, but I just graduated from undergrad, so I was tempted to immediately start a master's degree so that I would be able to do this program. And so I needed to find a topic and an advisor for when I'm back home. And I was lucky to have I talked with a professor who was teaching NLP, who was eventually my master's and PhD advisor. And then I ended up spending the first semester of my master's degree in the exchange program, student exchange program in Romania, taking some additional NLP courses. And then I went back to Israel and I joined the NLP lab, and I discovered that I actually enjoy doing research than taking courses. And then it was just an immediate transition to PhD, and then I decided I just want to stay in academia and keep doing research.
That's awesome. What was your thesis topic?
So it was about lexical semantics, or more specifically about acquiring lexical inferences. So that could be that's like a general name for when one word implies another word. That could be that could pertain to synonyms like elevator and lift, or hypernames like cat and animal. And all sorts of different relations. I worked on multiple different tasks in lexical semantics. I worked on discovering the semantic relationships between nouns, like I've mentioned, cat is a type of animal, cat has a tail. Also on interpreting implicit meaning in noun compounds. So, for example, interpreting olive oil as oil made of olives, but baby oil as oil used for babies, and all sorts of other tasks in lexical semantics, everything about the meaning of words.
And what approaches did you explore in trying to solve this problem or these problems? Sounds like several.
Yeah, so that's interesting because when I started, when I did my master's, this was just in the beginning of. This is around the time that Word2Vec was published, and everybody got excited about word embeddings and then other neural methods. But my first paper was actually not using any of these. I was using knowledge bases, specifically like Wikidata and DBpedia, just looking at these. Semantic relationships that connect words. Like I had a method that was that discovered these lexical inferences based on edges in the knowledge base. So, for example, if I don't know, Lady Gaga had an occupation of singer, and singer had a instance of person, so we could infer from that Lady Gaga is a person. Mm-hmm. And soon enough, everything turned to neural methods, and then I worked on detecting these either relationships by using neural nets, just trying to encode these the patterns that were connecting words in the text in a large text collection. So, for example, if you find text describing, I don't know, saying something like cats and other animals, or cat is defined as an animal, we were just encoding this with a network, and the network would learn which paths are indicative of the is-er relationship, which that was based on much earlier work in the 90s that was doing that, but we just interpreted it in a modern way with a neural net.
And so when you applied neural networks to that problem, was that a supervised application?
Yeah, so in that specific method, it was supervised. Yeah, and I did started doing more unsupervised and self-supervised work later on. At this point, that was before, I think in the last few years, it has been shown by many papers that supervised models have all these problems, that they just learn to, I wouldn't say memorize, but they learn very well the specific distribution of the training set, and then they are very brittle on any out of the main examples. So since then, I was trying to do more unsupervised work.
Okay. Tell us a little bit more about your recent work at the Allen Institute.
Yeah, so I've been working. Also, the team that I'm at AI2 and also at the University of Washington, we work on teaching machines common sense reasoning.
Okay.
Specifically in natural language. So the main idea is that because of the problem that I mentioned earlier, that the current models are very brittle, then if they had some kind of common sense knowledge and reasoning abilities, then they would be able to better address unknown situations using based on their common sense, like people do. And so I've worked on various things related to common sense reasoning. One of them is that I worked on. Sorry, let me rephrase it. Yeah, maybe I'll start by defining what I mean when I say common sense reasoning. So this is the basic level of practical knowledge and reasoning concerning everyday situations and events that are commonly shared among most people. It's obviously not global because it could be social common sense, which is culture dependent to some extent. But also some things are global, like physical common sense. Like if I drop a glass to the floor, then it probably would shatter. And some things like temporal common sense, like typical times and durations of events. They could be. There could be multiple options, but there's at least some common sense with respect to what's plausible and what's not.
Mm-hmm.
And so my work specifically, I had a model that tries to answer these question answering tasks pertaining to different types of common sense knowledge. And most recent models are based on using pre-trained neural language models. Okay. And what I try to do is to not just use these models to score the plausibility. So these tasks are usually defined as multiple choice tasks. Mm-hmm. So you can have something like, let's say, in something like the Winograd schema challenge. This is a pronoun resolution task. Mm-hmm. So you can have a sentence like, children need to eat more vegetables because they are healthy. Mm-hmm. And then the word "they" syntactically can refer either to the children or the vegetables. Mm-hmm. But then using our common sense knowledge, we can easily interpret that as, okay, the vegetables are, the word "they" refers to vegetables in this sentence. Mm-hmm. And so that was and most recent models for this task and for other common sense question answering tasks, they usually use the language model to represent the combination of the question and each one of the answer choices. So in this case, it would be like assigning the word children or vegetables instead of the word they. So like children need to eat more vegetables because children are healthy, or children need to eat more vegetables because vegetables are healthy. And then just using the language model to choose the better option. So it could be supervised, so that would just be a classifier that predicts which one is the correct one. Or in an unsupervised way, you could just use the language model to score the plausibility of each one of these statements. In
your work, are you only setting that up as a multiple choice problem as opposed to a fill in the blank type of a problem, or a free form unconstrained?
So in that work specifically, we followed the setup in which you just assign the answer into the context, and then you score each one of the statements, and you predict the one that has the better score. Mm-hmm. But we wanted to do something. Our inspiration was that when we reason about a sentence like this, we have this this background knowledge that is implicit in this context, but that might be helpful, like knowing that vegetables are healthy, and that vegetables make us healthier, and that people want to be healthy in general. And then we thought that it might be beneficial to make this knowledge explicit and just have this as an explicit text given to the model. So we developed this model that we call self-talk, that just self-asks a question, like what is the purpose of vegetables, and then generates the answer, and then answers it with something like vegetables can make you healthier, or vegetables are full of vitamins. And this is all based on neural language models. So the model generates the questions and the answers, and then using all these new facts to help it answer the main question.
Interesting. So the model generates some set of questions based on the passage that it has ingested, and then it tries to answer those questions, and then based on all that data, it then tries to predict the answer to the original challenge.
Exactly, yeah. And we had this set of generic information-seeking question prefixes. So we did guide it to ask more about definitions and purposes and things that we saw that these language models are pretty good at, as opposed to, I don't know, for example, they're not very good at detecting causes and effects. Mm-hmm. So we didn't try to generate these type of questions.
Okay. And how many questions typically would the model generate for a given challenge paragraph?
Some tens of questions. I don't remember exactly the number, but around maybe 15 or 20, I think.
And those questions were, you mentioned that you had these, I don't know if you used the word templates, but were they templates that the model was plugging into, or were they classes that it was trained to generate?
So it's more like the prefix. So the model can get a prefix such as what is the definition of, but then it generates the rest of the question based on the context. If it gets something like the context with the vegetables and children, and then what is the definition of, it's usually going to ask about one of the words in the context, but it's also not constrained to that. It could ask something like, I don't know, what is the definition of healthy lifestyle?
Yeah. So in that sense, what the thinking is that you will take this, you've got this paragraph, and you'll apply a language model kind of hierarchically, where you're kind of preconditioning it to think about the context and elicit the common sense that it may have access to. And then you're, based on all of that, asking it to make a decision as opposed to just making the decision.
Yeah, exactly.
And what did you find?
I did manage to improve the performance on most of the tasks that we evaluated on. We did find some interesting. I mean, this is very much a first step in this paradigm. We still have a lot to that we plan to improve in future work. But one thing that we found is that when we looked at the knowledge that was generated, it was so most of it was grammatical and understandable, which is expected because we know that neural language models are very good at generating fluent text.
Mm-hmm.
And also in most of the cases, it was relevant to the context. And it was usually also factually correct. I guess it has to do with the fact that we did constrain it to generate types of knowledge that we knew that these models are good at.
Yeah.
But something that was interesting is that when we asked human evaluators to judge this generated knowledge, they didn't find, so we looked at the knowledge that was in practice helpful for the model. So these are the cases in which the model failed to predict the answer correctly without the knowledge, and then once given the knowledge, it predicted the answer correctly.
Mm-hmm.
And then the evaluators didn't, only in 40% of the cases, they consider this as helpful knowledge. So I thought that was interesting because it might mean that there is some discrepancy between what helps the model in practice and what humans consider as helpful knowledge. I think there is also some limitation here about when you ask people to consider whether some kind of knowledge is helpful for making a decision. I think they might not be very good at judging that because things that are very obvious to us, like something like people want to be healthy, might not be obvious to the models. And then a person judging that might say, no, the model doesn't need to know that. It surely already knows that.
Mm-hmm.
So I think that's interesting. I don't know yet. We're still thinking of ways to guide the generation towards more helpful knowledge, or maybe ways to judge whether knowledge is helpful, it's going to be helpful or not.
Got it. And which pre-trained language model did you use for these experiments?
We used a bunch of them, mostly the GPT-2 models in all the different sizes.
Okay.
There's also the distilled version. We also use GPT and ExcelNet. I think GPT-2 was the best of them, and typically the larger model was the better one.
Mm-hmm. Okay, and I guess it's not really surprising that the larger model was the better one, but I can imagine. I don't know. Was that surprising to you? I think. I wonder what the fidelity of the knowledge that the language model creates is necessary for it to refine its ultimate answers. Did you do some kind of sensitivity analysis to the size of the language model?
I didn't. I do think that the larger models are probably capable of memorizing or learning more facts from their training corpus. But there's probably some limits to that. I'm assuming that I don't remember exactly, but I don't think that I don't remember for sure that the GPT-2 extra large was always the best. But typically, yeah, they were better than the smaller ones. I think that we had some cases in which maybe the large or the medium size was better. In general, yeah, the larger the model is, the more knowledge it captures, or I don't know, the better the easier it is to extract back this knowledge from it.
And did you look at? Did you apply that same when you were asking the humans to evaluate the informativeness, the utility of the generated sentences? Was that, how did that correlate to the size of the language model? Did you look at that at all?
I did. I actually don't remember these results. I don't think it was. I think I didn't have enough instances to make a significant statistical analysis for it, enough instances from each language model. So I don't know for sure, but that's an interesting question to check in the future.
Nice. Do you also look at in your research kind of multimodal reasoning, incorporating images and other types of modes to try to augment this common sense reasoning capability?
I haven't done that yet personally.
Okay.
Some people in my team are working on this area. I do think that it's very important to work on that in the future. I think that one of the issues with working on teaching machines common sense reasoning is that we need some way to acquire this knowledge and so that we can have it in a machine readable format. And in the past, it was more common to either collect it from people or to extract it from text. And then the first approach is not scalable because it's impossible to manually enumerate all the common sense knowledge in the world, and it's very costly and time consuming to try that. And then the second approach of extracting from text is it works, but there is this problem of reporting bias. That's because people tend to speak more about the exceptional than they speak about the obvious. So that's reflected in the text corpus. And then if you, for example, look at the frequency of occurrences of mentions in the text, then you might learn something like that people murder more than they breathe. There was a paper about reporting bias in 2013 that discussed these issues, and then there's also this possibility of extracting this knowledge from language models, which, as we just talked about, is to some extent promising because they can generate knowledge even when it's not mentioned explicitly in the corpus, because they're capable of aggregating different contexts and learn. Like, I don't know, in one context something was mentioned about. Continuing with the same example, so let's say that one context mentions something about vegetables containing vitamins, and then there's another context that says something about vitamins or something that's essential for people's health. Then these models, they know how to aggregate these contexts, and you can then generate a sentence that was not even mentioned as is in the corpus originally, like that vegetables make you healthy. Mm-hmm. But then they're also limited because they don't completely overcome reporting bias. We had a paper recently in calling in which we show that even though they are good at assigning a non-zero probability to events that are very obvious and might not have been mentioned a lot in the corpus, they have this the other side of the problem in which they tend to amplify the more exceptional, more sensational outcomes. Like I've had this example in which the model said there was a sentence like the men turned on the faucet, and then GPT-2 generates something like the men's blood was sprayed everywhere. And that's not uncommon. I mean, it happens once in a few times that I generated text. And so this multimodal, like learning common sense knowledge from additional modalities, is helpful in the sense that you can collect knowledge that might not be mentioned in text. Like I have this example where I don't know if it works without seeing the image, but there's this image of like a class photo, and there are kids in the first row that are sitting, and then those in the last row are standing. And if you look at enough class photos, you might learn this rule that the kids in the first row are typically going to be sitting, or at least, I don't know, if they're standing, then it's likely that also those in the last row would be standing, which is not likely to be mentioned ever in text.
Yeah.
But then again, like you have to be careful not to learn reporting biases from other modalities. Like if you learn from the movies, you might learn something like that people typically hang up the phone without saying goodbye.
Mm-hmm. So on this topic of reporting bias, did your research speculate as to why this happens? Where does this blood splattering out of the faucet come from?
I think so. First of all, it does depend on the training corpus of the language model. So we did see some differences between. So we had several experiments. We did see some differences between models trained on Wikipedia, for example, and models trained on the web. But models trained on the web, they have been exposed to a lot of news. So they do have this bias towards events. I don't know, like if you start generating with GPT-2, eventually someone's going to end up in a hospital or something. It's always like something that's newsworthy. So I think it's probably because of the training corpus.
Mm-hmm. And was your work looking at if language models exhibited this, or neural language models exhibited this more than non-neural models? What were you, it sounds like you were kind of implicitly comparing with that 2013 paper and some of the models that looked at. What did you see as the differences between the two classes of models?
Yeah, so I was comparing with the extractive models, the models that just look at the text itself. So, for example, when I was looking at the likelihood of trying to estimate the likelihood of actions performed by people or happening to people, like being born or dying is something that happens once in a lifetime, as opposed to something that's as common as breathing or talking, or something that is very rare, like getting killed, which has a much lower probability than one because it doesn't happen to most people. And so I compared it with real world probabilities and with extracting this from a corpus. I was using Google Ngrams and just trying to look at phrases of like the person is doing something, the man is doing something, or something happens to the person. It's not optimal. Also, the way that I was using language models to generate it is a bit debatable, because there's an issue. There's something that is now known. It has been discussed in several papers since, that language models are sensitive to the phrasing of the prompt. So, like you could get very different probabilities for statement like the person was born, as opposed to, I don't know, the man is born, or something. Depending on the way that you phrase that, it's going to be different. And also, when you use these models to complete the statement, people do something every day, and you try to replace this something with a word, then it might predict something like, maybe this phrasing is not good, but like people something every day, and it might replace it with breathe, but then if you phrase it as I something every day, and it's going to replace it by a different word. And I did try when I tried to estimate the likelihood with using language models, I did try various different phrasings, but just the fact that something is that I don't get the answer that I'm expecting doesn't actually mean that the language model doesn't know that. But it might just mean that I haven't found the correct phrasing to extract this knowledge. It still is problematic, because you have to know how to tweak this prompt in order to get the knowledge that you want. And the fact that it's not consistent is also a problem, because it means that in some cases you're going to generate the incorrect answer.
It sounds like it's largely a trial and error type of process, as opposed to learn how the language model likes to see things phrased to get the kind of answers you want.
Yeah, and also So depending on the language model and the way that we use it, if we use a model for generation and not for filling in the blank, then typically we're sampling from the language model. So it's probabilistic, and you can get different answers every time you generate text. So there's a lot of randomness here, and it's very useful, but it's not it's not a reliable source. Not enough yet.
And is there any noteworthy research that comes to mind, folks that are trying things to overcome this phrasing issue?
Yeah. So there were two papers recently. I can find the titles later. There were two papers, I think one from CMU and one from UC Irvine, I think,
Okay.
that learned to rephrase these prompts automatically, and then I don't remember the differences between the papers, but they were both doing something similar, like trying to change the prompts in order to. Oh yeah, I remember the paper from CMU was trying to come up with various paraphrases for these prompts in order to increase the likelihood of generating the correct answer, and then somehow aggregating across the different answers obtained from these different prompts. And then they were using paraphrasing approaches to get these different phrases. And the other paper that I mentioned, I think they were trying to, they were targeting different tasks, but they were trying to add these specific words into the prompt that would increase the likelihood of getting the correct answer. Okay. I might not be describing it very accurately, but those were like two papers that I liked that were trying to overcome this sensitivity issue, sensitivity to the prompt.
And these issues with the phrasing of the prompt and the techniques outlined in the papers you just mentioned, are these things that you're looking at, or you think would be interesting to incorporate into the previous model where we discussed, where you're generating these kind of knowledge questions, which you can think of as prompts, and maybe if you had a model that generated variations of them, is that something that you've done?
I haven't done it, but it's definitely, and that's an important direction. I think that while I was working on this model, I didn't know yet how sensitive these models are to the prompt. One other thing that we were thinking of doing is that in that model we were using, so we wanted to measure the plausibility of statements, and there's no way to measure plausibility of statements to date, but we were using this standard proxy of just using the language model score. So just inputting the statement word by word and computing the conditional probability of each word given the prefix, and then using the entropy to determine which statement is more plausible than another, and that's very much suboptimal. I am looking at better ways to estimate this from language models, because one of the issues with this is that it factors in other things like the length of the statement. I mean, you can divide it by the number of words, but then now these models work at the subword level. So sometimes if you have a rare word, it's going to split it to multiple tokens. And then you have this issue where if you take a long word that has been that is split into multiple tokens, like what was the example I was using? Some velociraptor. Then if you split it to like 3 tokens, then at the third token, your conditional probability is already going to be, there's not a lot of surprisal there, because you've already seen a large part of the word. Then there's a very high probability to predict the correct next token, as opposed to if you if you have a short word or a word that is very common, you have all these issues that they're not about what is more plausible in the world, but they're more about like how like if you split this word, like how probable it is to get each token. And then also yes, so these two issues of like the length of the statement and the frequency of words and the way that the language model decides to split it into subwords affects this score a lot. I am trying to maybe test all the different variants of like how to divide this the score by the number of words or the number of tokens, or maybe disregarding the frequency of words, just trying to divide it by the frequency of the word in the language, and trying to maybe factor out these issues. But I don't have any results for that yet. I think that maybe, I need to study it further.
Is another challenge in that approach to plausibility kind of the self-referential nature of it, and like you're still dealing with the reporting biases and other biases inherent in the language model?
Yeah, I mean that's definitely an issue. Yeah. If I understand your question correctly, so even if I did have a way to get from the language model the plausibility, factoring out the language issues, then it's still going to be subjected to reporting bias based on what it has observed in the corpus. Yeah, definitely.
Right. And I guess another way to ask the question is, did the language model think that blood spouting out of the faucet was plausible in the first place, and so it would rate that highly?
Yeah, I mean, I did. It did generate that when I was using pretty standard values for the sampling method. So to some extent, the model does consider that as plausible.
Mm-hmm.
There's also, I have to hedge that a little bit and say that part of the problem of coming up with a better plausibility measure is that it's not clear how to, like, if I would like to collect this data from people and ask them to rank something for what's more plausible or what's less plausible, mm-hmm. I don't know how I would define plausibility.
Right.
It would have to be, I mean, I have read a little bit about this in other fields. There's a lot of literature on that in cognitive science. I haven't found very accurate definition of what is plausibility. How do you define what's more plausible than other things?
Mm-hmm.
I do think that like some things are they have to like follow some physical rule, and then if something doesn't follow that rule, then it might not be plausible. But it's hard to find anything further.
Physical rule meaning, in accord with the way the world works, or in terms of the language, not a grammatical rule, but a physical rule that is trying to capture the way the world works.
Yeah, exactly. I was talking about the world, but then it's really hard when you use a language model to estimate these probabilities. It's always going to be in some way also looking at the way that people talk. Like if I did, one of the comments that I got from my calling paper about reporting bias in language models is that some of the phrasings that I was using are just not natural. So I can't. I mean, it goes back to this is like this circular problem of reporting bias, because people don't say something like the banana is yellow, but they might say something like the yellow banana is is tasty. Yellow bananas are good for making banana bread.
Yeah.
And so it's really hard to put this to differentiate between how natural something sounds in the language and how plausible it is in the world.
Mm-hmm. Yeah, one of the thoughts that this conversation prompted for me was, would it make sense to have your primary language model be one kind of trained on news and the broader internet, and then use some language model that's more constrained, like Wikipedia entries or something like that, to judge plausibility, with the thinking being that, maybe you want the richness of the freer model. But, on the other hand, should you if you really want to constrain with the plausibility of a Wikipedia model, should you just use that from the beginning? Any reaction to, like, what are the issues that kind of thing raises for you?
Yeah, I think it's a good idea to dedicate portions of the training data to different functions. I think that might work. And I agree that if you want to have this like fluent language model that knows a lot about language, then it's good to train it on just more data. And then you might want to use just a part of this data to estimate probabilities or plausibility of events in the world. Mm-hmm. I still think that a Wikipedia model is not going to be a lot better. I mean, because Wikipedia also talks about these famous people that I did actually have one finding in that paper that I think Vereds estimated, or a model trained on Wikipedia estimated dying as more likely, because a lot of the entries are in Wikipedia are written about people that have been famous in the past, and many of them died already.
Yeah.
So you do have these issues with Wikipedia as well. But maybe a different solution is training these models also on some human curated common sense knowledge bases, as there's the Comet model from 2 years ago, from my team, but I wasn't involved in it. So that they fine-tuned GPT on knowledge base, common sense knowledge base. So there's a knowledge base called Atomic that consists of triplets of event, and then there's some dimension and another event. So for example, you have a person adopting a cat, and then you have a dimension could be something like what needed to happen before that. Maybe the person had to go to a shelter, or why did the person do that? Because they were lonely, or because they wanted a cat. So the Atomic knowledge base was collected by crowdsourcing. People collected it. It was elicited from people, and then the Comet model fine-tuned GPT on this knowledge base, and then you can use it to also generate this kind of inferential knowledge about unseen events. And it's really nice. It works very well. There's also a demo for people to play with. So I think that's a good direction, combining this symbolic knowledge found in knowledge bases with this generalization and flexibility of language models.
Interesting. Well, Vered, thanks so much for joining us to chat about your research. Very cool stuff.
Thank you so much.
Thank you.